Hello everyone. I hope you guys are doing well. Today we are going to discuss the particular case of the linear differential equation, that is the Bernoulli's equations. Okay, Bernoulli's differential equations. And Bernoulli's differential equation, an equation of the form dy upon dx plus py equals to qy to the power n, where p and q are functions of x or constant. Okay, functions of x alone or constant, and accept 0 and 1. Okay, where n is constant, so there should be written here, or constant, and n is right, n is okay, because we have n here, n is constant except 0 and 1. It's called the Bernoulli's differential equation, right? An equation of the form, right? Remember, see this, dy upon dx plus py equals to qy to the power n is Bernoulli differential equation, where p and q are the functions of x alone or constants. Okay, and n is constant except 0 and 1. It's called the Bernoulli differential equation. Okay, and one remark here, equation dy upon dx plus p1x equals to q1x to the power n. If we have dx upon dy in place of dy upon dx, and here we have p1x plus q1x to the power n, this form of the differential equation, linear differential equation, so it is also the Bernoulli form of the linear differential equation. Okay, and p1 and q1 are functions of y alone. So what about the working rule to solve such type of differential equation? The working rule are, if we have the differential equation in this form, then first we divide it y to the power n, that is the coefficient of y to the power n. First we divide it y to the power n. Okay, and after dividing it y to the power n, then we get the resultant as y to the power minus 1 dy upon dx, right? And y to the power minus n, y to the power 1 minus n into p equals to q. After dividing y to the power n by this equation, to this equation, right? So we get y to the power minus n dy upon dx plus y to the power 1 minus n into p equals to q. So in the second step, what we need to require, we will suppose y to the power 1 minus n equals to v. Okay, and then we differentiate the given differential equation with respect to, so let y to the power 1 minus n equals to v, then differentiate here this equation with respect to x. So we can write 1 minus n here, and y to the power 1 minus n minus 1. So you will get y to the power minus n dy upon dx equals to dv upon dx. So after simplify it, after dividing 1 minus n the complete equation, you will get this finally. Okay, and put these relations, whatever you have considered here, in the equation number 2. Okay, so you will get the resultant as 1 upon 1 minus y dv upon dx plus pv equals to q. Or you can convert the given differential equation dv upon dx plus p1 minus v into v equals to q into 1 minus n, which is a form of linear differential equation. Now you can solve this linear differential equation with the help of working methodology. Guys, we solve this question based on the theory of Bernoulli's differential equation. So now we are dealing with the solution. Okay, the given differential equation is dy upon dx, then plus x sine 2y is equals to x to the power 3 cos square y. Obviously the given form is like dy upon dx plus p and p gy is equals to q fy, right? Which is the another form of Bernoulli's, which is the another form of the linear differential equation, and which is treated as the Bernoulli's differential equation, right? And simply we solve it by dividing the f of y, the complete differential equations. So now divide the differential equation by cos square y. So you will get 1 upon sec square y, sorry, cos square y, right? Cos square y dy upon dx, and then plus x sine 2y means you can write it as sine 2 sine y cos y is equals to x to the power 3 and divided by cos square y. So simply this square is cancelled out, and you can write it as sec square y and dy upon dx, and then plus 2x sin y upon cos y is 10y is equals to x to the power 3. So we have this form of the differential equation. Now you can find here, this implies that consider v is equals to 210 v equals to 10y. Okay, simply consider v equals to 10y, then this implies that dv upon dx is equals to sec square y and dy upon dx. Okay, so now substitute these considerations in the above equation. You will get here dv upon dx, okay, and then plus 2xv is equals to x to the power 3. Now which is a first class linear differential equation, okay, linear differential equation in v and x, remember this thing. Okay, now what about the solution? Before going to the solution, we will find the integrating factor. So integrating factor, from it you can find the value of p. The value of p of x is equals to 2x, and the value of q of x is equals to x to the power 3. So what about the integrating factor? E to the power px integral px dx. So e to the power integration 2x dx. This implies that e to the power x square, which is your integrating factor. Okay, now what about the solution? Solution is your v into integrating factor e to the power x square is equals to integration, and what about q, that is x to the power 3, and what about the integrating factor e to the power x square dx, then plus c. So now to solve this, we can simply consider, we need to find this integration here, simple integration here. Okay, and what about this integration? Now consider x to the power x square is equals to t. Okay, this, consider this power equals to t. So you will get here 2x dt upon dx. 2x is equals to dt upon dx. So from here you can write x dx is equals to dt by 2. Okay, finally you will get the result as v into e to the power x square is equals to 1 by 2 and integration of t e to the power t dt, t e to the power t dt, and plus c. Okay, because x dx is equals to, you can write dt by 2 here, and x square means t, so you can write it as. Now simply integrate this function. So 1 by 2, you can consider first function t, integration of second function, right, and then minus derivative of the first function t is 1 and integration of the second function t is e to the power t and dt, right? So plus c. Now what about the final result? And you can write it as, that is v into e to the power x square is equals to 1 by 2. You can take t e to the power t and minus e to the power t, okay, and then plus c, okay. Now which is 1 by 2 t minus 1 e to the power t plus c. Now substitute the value of t here, 1 by 2 x square minus 1 and e to the power x square, then plus c. So which is your required answer? Okay, that is v into e to the power x square, or you can write it collectively, v equals to e to the power minus x square and 1 by 2 x square minus 1 e to the power x square and then plus c, which is your final answer. So guys, you can solve very simply. First, convert your given differential equation into the linear differential equation. Then solve it by the working rules for the linear differential equation, and by this process you can simplify the answer.